Welcome to Brain Vision.
For this question, we have to use a very uncommon trick to solve it. So instead of choosing a reference frame like this, we will choose a curved reference frame. And by that I mean the following. This will be our x-axis or y-axis, as you like to call it. I will call it the y-axis. So everything that is pointing in this direction is pointing to the positive direction, and everything that is pointing to the other direction is pointing to the negative direction. Then, by doing that, we can apply Newton's second law to the whole system. By the whole system, I mean this together with this. Then, this results in the following. The net force on that direction is equals to the mass of the whole system, so m1 plus m2 times the acceleration of the whole system. Let me call it A. And now we write the net force. The net force is composed by four forces. The weight of the second part, the tension again, and the weight on the first part. And this goes as follows. The weight number 2 points to the negative y direction, so minus weight number 2. The tension number 2 points to the positive y direction, minus the tension number 1, which points to the negative y direction. Note that both tensions are equal because the cable is considered here to be an ideal cable, so it can't be stretched nor compressed. And then we have the weight force W1, which points to the positive y direction. And this is equals to the whole mass times the acceleration of the system. Then we have a cancellation here of the tensions. And then we get W1 minus W2 is equals to M1 plus M2 times A. Remember that the weight force is given by the mass times the acceleration of gravity, which is approximately 9.8, and then we get the following. The acceleration of the system is equals to m1 times g minus m2 times g divided by m1 plus m2. So the acceleration is equals to 21 times 9.8 minus 45 times 9.8 divided by 21 plus 45. And this results in an acceleration of approximately minus 3.56 meters per second squared. It means that the system will accelerate in this direction. So this part will go down and this part will go up. And this happens with an acceleration of 3.56 meters per second squared. This is the absolute value of the acceleration. Now, for the second item, we have to calculate what is the tension in that cable. For that, we apply Newton's second law either to this system or this system. So let me apply to this system. Doing that, I get the following. Oh, and now I'm using this reference frame. For the second item, this is my y-axis. So this was for the first and this is for the second item. Then, on that y direction, the net force is equals to the mass m number 1 times its acceleration. The net force is composed by two forces, the tension and the weight number 1. Then we have the tension pointing to the positive direction minus the weight number 1 pointing to the negative direction being equals to m1 times A. So the tension is equals to m1 times A plus W1. Oh, this is acceleration of the weight number 1. And now, note that the weight number 1 will go up according to our answer for the last item. Then, the acceleration A1 is equals to 3.56 meters per second squared. So the tension force is then equals to M1, 21, times 3.56 plus M1, which is 21, times G, 9.8, resulting in a tension of approximately 281 newtons.